We go to Start Program, and then we have the Oracle BIE Intelligence. We start the OC4J application, which is a substitute for the IIS in a short condensed environment, like a Demo.1 we have. And with that, we make sure we have the OBIEE presentation server and the OBIEE server, the web and the app servers are up and running. So once I have my basic settings ready, services ready, I'll go ahead and launch my application, which is for that I'm going to go to administration, and then we can see, finally to validate, we can see presentation services, which is the actual application. So let's click on administration. That's the tool, the OBIEE administration tool. As we said, there are two ways to open the file. There is an offline mode and there is an online mode. So let's open the offline mode first. It has taken me to the location where the OBIEE server is, and under OBIEE on a server, under repository, I have these particular files available. Currently, my settings are that I am using these are demo.rpd. I'll use another one, the paint.rpd, which is provided as a demo by the Oracle BIE out-of-box configuration. Let's open that. So enter the login and password information here and with this particular demo application. So as I said, we'll go for the navigation aspect and the various menus what they provide, and then we'll go to the individual planes. On the file, you have different components to import data, the regular new, close, save as, copy as configuration. The importing feature where you can import data from the metadata, I would say, from the different options like the database or the different repository or an XML file, and that's to get things started on the repository. You have feature to compare two different repository files. Then we have a merge in case there is information from another repository which you want to plug together, so that's the merge feature. We have the check global consistency. This is for doing a kind of a validation by the application to check whether configuration you have made in the repository is it fine or not. So in case it's not a compile actually, it's because, as I said previously as well, the repository file is a single file which is generated. You don't have a bunch of configurations set up and all together like the Siebel systems which have the compile in the tools and finally you got a kind of file. Here you have start with the RPD file, you make the changes, you save the file, and that's your RPD file to be used. The only thing available is this is the check global consistency. It will check for any logical error or syntactical error, I would say, but still you can make mistakes and that will be accepted by this. It's just checking the syntax and different configurations, some guidelines, basic guidelines are checked. So it can give you a warning. Let's do that for a minute. So I just ran it and it brings me to this particular plane. And it shows me different, I'm checking for errors, warnings and best practice, and this particular instance does not have any. So it's perfectly fine. In case you have warnings, those will come in here and show you it's an error and different things. A few examples of talking about what could be the error. Suppose you have a repository, a logical field which is a logical table which is not joined to any particular fact table, or you have a logical model defined but you do not have a present tense layer corresponding to it. Such kind of things a repository can check by itself, and that's part of the global consistency check. It's a handy tool to validate your changes. The edit is a very regular edit menu. The view refresh. Again, so the important one is the manage. Initially you see this 4 grayed out options, as these are only available in the online mode. The jobs, the session, the class, and the clusters, these are only available in the online mode. We'll check on them a little later. Then we have the security. This is the place where you define your different groups and users. So if you wanted to set up a new user, you could set up into this particular location saying new, and you can set up a user, and it will open up a log-on box. You can set up what is the username, the password for that particular user, and which groups you want to assign to. The user setup in an integrated environment, in case you have a Siebel application and a Siebel Analytics and implementation integrated, you will not be doing the user setting here. You would basically have the administrator login, the primary source of getting into the repository as well as the application, but the other users may not be required here. In case you have a standalone application, so this is the place where you will be doing that. Groups, these are required. You set up your responsibilities or groups. So in the Siebel world we call it a responsibility, in the analytics world we call it a group. But for analytics, whichever groups you create over here have to have one-to-one mapping with the ones created in the Siebel application as well. So that's mandatory. Then you have the setup for the LDAP server. This is a demo application, so it does not have an LDAP security. But that's again, if you wanted to create an LDAP server configuration here, you could have done that. Any group hierarchies, if you wanted to set up that this group belongs to a subset or a secondary child group to another one, that's the place you can do that. So that was about the security menu. Joins menu, you can see all the joins for different tables which you have. As a best practice, you may not want to use this option to check the joins, and you want to use the diagram, the physical diagram or the logical diagram, which we'll see at a later point of time. So I'm just going to skip this. Just click on here. It's just going to show you all the different joins. This is a simple demo application. That's why you just have few of them. In your actual application, there will be tons of joins, and even this showing up this particular screen will take a bit of time. So that's not even the ideal place to go for doing the joins. Yeah, it's just a location where you can check in case you need. The next one is projects. So this is used for the multi-user development setup. So if you want to set up a project, you could set up a new project here. Right now we don't have anything. I could set up a new project and say we divide the work between two people, developer A and developer B, and we define some projects like we have, let's say, some kind of opportunity subject area which is given to developer 1, and then you have a service request subject area which is given to developer 2. So you might create two different projects, opportunity project and a service request project, and give that you will be able to segregate the repository into two people or groups of people, and they can work independently. So that's required for multi-user development only. Otherwise you will not be doing it. It's not necessary. Marketing we are not going to talk about. This is only if you are implementing the marketing application. Let's go into the tools menu. So update all row counts. So this is a feature which once you operate that, in the physical layer, all the tables will go and check for the row counts in the corresponding tables, and they will be updated. They will be stored directly in the repository. It's not showing, so it's not done. Let's do that now. So ideally when that is done, what it does is when you go over the particular table, the tooltip will show you how many records that particular table has. Not that is necessary, just a feature in case you want to do stuff in the repository itself. Show global consistency checker is just a window which we saw some time back. Query repository. This is another handy way of finding information in the repository. So suppose you're working in a repository, you want to find where all, let's say, the word paint is used in the logical column. You have different options to choose, find information about. So let's say I want to find which all particular presentation tables have the word paint in it, or are equal to the word paint. I might search that. In this case, nothing. Let's check for the logical tables. This might take something starting with that. Oh, we do not have a paint. Let's say market. We want to find market. I'm just taking a simple example. Table. I can query and market. So let's put a aspect and just check it that way. We find different attributes. It's very handy. In this particular example, I was just giving a quick demo, but it will be very handy to find when you have a huge repository with multiple subject areas and you want to find where all these components are. You can find for different things. So you can find for physical tables, variables, projects, all kind of things you can find. Usually it's useful to find presentation objects or physical objects into the repository. So it's a way to query your repository itself. If you want more details into it, the show qualified name, so it will give you the attribute starting from the name. So this is a logical table, so it will start with a logical core model, that is paint, and then it's market. You can always double click on that particular entity and check more information into properties tab. That was about querying the repository. Then under the tools we have the utilities. This provides a set of features which you can try and do in the repository. I'm going to go in each of them, but just a few of them. The repository documentation is one of the features where you can extract all this information that you have in the repository and into an Excel file. It's a very handy tool to get all this information to an Excel, and then you can pass it to the developer or the designer, somebody who is not used to the repository but wants this kind of information. So it will give you good metrics kind of information about the whole repository metadata. These are different features. I will let you explore it in leisure time. Each of them could take quite a bit, and they're more advanced features. In real development, you will not be using most of them. In day-to-day development, I mean. Then you have some option setting which you can do at different levels. These are more like how do you want to see the particular thing, how you want to view, show a toolbar, and different kind of major setting and things. Most of the time, I just let the default run to it and say unless I need a specific change in one of the settings. And then you have always the help. The help is pretty handy. You can get lots of topics here answered. You can get, it provides a very robust mechanism to answer the whole set of things, how the repository is done. This is very powerful. It's not just a simple, if you want any kind of information more on querying, query cache, you can go into this and you can find all that information, the architecture, and different things. So it's a good place to look for information in case you get stuck or need any information on the repository. So that concludes our first portion of the thing about the navigating the different menus in the application. First, the physical layer. As I said, this is a place where you find all your physical connections. So here in the demo application, they have two different connections mentioned, the forecast and the paint. Let's go on the paint. Forecast, and the forecast has a connection pool defined XML underscore forecast. So that's the symbol for a connection pool. So what does the connection pool provide? Provides all the information for a data source like its name, what kind, if it's a secured one, what is the login and password. So if we have a database, it might have the DB login password, multi-threading. So all the initial attributes to connect to the information. It has an XML feature in case it's an XML source, which this happens to be. The demo provides both these connections to be an XML connection. At this level, you can define in the initial level what kind of a database it is. It's an XML database. It is all kind of features are available. You can have Access, Oracle, ODBC, all kind of Teradata, a set of even SAP is provided. So this level is different kind of databases you can connect, and correspondingly there is set connection pools for each of them. So these are some features for this particular connection pool. Sometimes it gives you an error saying that it is not the default and you can revert back to the default. It has one connection pool which we talked about a little bit before. Let's go back to the details of this connection pool. So this particular connection pool is very simple. It has only one table into it. That's the forecast table. So that's a physical table right there. It happens to be an XML data source, but it's a table from the physical perspective. It has 4 columns. These two are the keys, the key symbols, and other two are the columns, simple columns. Let's click on the table. So it's a physical table. You can have a select clause, which could be, if you want to put a equal, which is just a subset of the table. Let's say where the particular flag is equal to yes, you can do that. You can call for source procedure. You can make it cacheable and caching configured. This has 4 different columns. The data types mentioned here. The key. So it has a key defined on 2 different columns, the market key and the person key. The foreign keys are joined to this other table. And some XML attributes, so what's the location where the XML is placed. Let's go on the other one, it might have more information there. The paint one has multiple different tables. This particular symbol is showing that this is not a true table, but it's an alias or a select clause. It's an alias table. It's coming from the different table source. We'll talk about alias a little bit. So it's tricky. So how you add tables into this? There's 2 ways. You could simply go ahead and right click and create a new object, a new connection pool or new physical table as you need. This is not the ideal way to do the physical tables. Actually, said in the best practice, it's a good way to find, import, and import from the database if it happens to be database or XML or a repository. Most of the time, 90% from the database. Creating an alias, what will happen is you will right click here and create new object from here, and you will, on this particular table you are performing the operation. So you can create a new physical column, key, but let's say we want to create an alias. So here is the place. So this is going to use this table as a starting point and create a new alias which will have the same set of columns as this particular table and the same schema. This will become a read-only. We got a test table. You see the icon is automatically created the same one as the initial one. This is totally grayed out. You cannot do any changes. While in this particular case, you can do changes if you want it. Any change done to the initial one. So if you add a new column into this one, the same change will be reflected back to the test. I'm just going to knock out. So that's the way, a tricky way. It's not, if you look for the UI, you may not find how to create an alias, and the alias is automatically created. Some of the alias. So that's the way to create an alias. It's not set there. So we saw that the physical layer could have connections, the connection pools, and tables within it. The next important attribute to look for is the joins. So usually we have a star schema. So you have a central fact table joining to the different dimension tables. Here already solved joins and made already for the demo application. We're just going to take a look at that. We'll right click on the fact and then go into the physical diagram. And there are different options where you can look at which all different joints you're looking for. So a physical diagram is the way which different tables are connected, the relationships, the column level joints can be shown. So I'm going to pick up select this object, the fact, and its direct joins. Here it is. So we got the central fact table, and these are 3-dimension tables which it is connected to. And as we were saying, this is a good place to create the joints and not the manage joints location. So it has a fact table and 3 dimensions which are joined to it. Let's look into the join, what particular join we have. When it says double click on that particular line, you notice what are the key fields which are joined between this fact and the dimension table. The table market is joined by the market key field with the fact market key field. And if I move it to here, it would automatically change the join condition to product field. I don't want to do it, so I'll just cancel it. The way to create a new join. So these are the 2 icons which are used for creating joins. First is a new foreign key. So this is the physical join which we are looking at right now. This particular join method is called as a complex join, will be used in the logical layer. This is already created, we just viewed it, but if you were to create a new one, let's take this and let's create a new one. I'm going to delete this one, delete the existing. So if I wanted to create a new join, what I'll do is, I'll just do a single click on the new foreign key icon. First I have to select the dimension and just fill up as a line join and just put in the fact, and it will pop me up with this particular location. And I'll say okay. But I see already the market key and market key already joined, but it looks fine, and that's the way to create it. The reason I picked up the market first and the dimension second, the fact second, to see this particular throw leg kind of thing shown, it's showing the one-to-many relationship. So one record in the market dimension is joined to multiple records in the fact table. So that's the way to create the joins. You specify all the joins which you want for this fact table, which results into this as your star schema. So you have the central fact in this particular star schema, simple one. Let me close that. And that pretty much covers the physical layer. Anything you want to know, anything specific? In the business model layer, we have one particular PM model, which is the paint. Initially, the first 3 hierarchies are mentioned as the tree which defines your conceptual hierarchy in the layer. The yellow icon one is the fact table, which corresponds to, I guess, this particular fact table, physical fact table, which we saw just now. it also has the BM layer. It has dimensions, the facts, and the hierarchies. So let's first look at the fact table, or maybe let's look at the joints in the fact table. So we have the joints specified in the physical layer. It's also needed to define joints in the BM layer, and we'll go this time right click the sales fact and we'll go into the business model diagram, not the physical. Here you could also go to the business physical layer diagram as well. Here we'll go to the business model diagram, select selected tables and direct join. Open for me the logical table diagram. It has the sales fact at the center, and again the 3 dimensions. The difference this time, let me click one particular icon. I don't know, this seems a little odd. In a physical logical diagram, you do not give you the explanation. The keys are not needed. You do not define the keys. You just define the tables. And the main purpose of the logical diagram thing is to provide, it's an option for providing 2 things. One is the type of a join. Mostly it's going to be inner join. And sometimes there will be a need for outer join kind of scenario. So this is the place where you will configure that. Then there is another feature of the driving table. This is used for better performance. Suppose you're joining 2 tables, and let's say the sales fact has, let's say, 1,000,000 records, and the product table only has, let's say, 1,000. So the ratio is pretty much, there's a huge difference. The product table is very small compared to the sales fact. In that kind of scenario, setting up a driving table to be a product will help in the performance. The SQL being generated will first look in the smaller table, filter it down by that, and then accordingly look for the corresponding table. So it helps in execution of a better performance tuned up query. So that's the usage of the BM layer join. You can define a driving table and you can define a type of join. Ideally, you do not want to have an expiration out here. But it's a demo, I will just leave. Maybe that's from XML source. Just after that, I will just leave it that way. So there is the join defined in both the layers, and they have some specific purposes in it. These are the joins for the BM layer. Let's go into the different components layer. So we have saw fact table. We'll come back and look in more details about the fact table. We have the dimension table now, the market dimension, which has 3 different sources into it. So this is a very good example to what the difference between the market table and the logical layer compared to the market table in the physical layer. This particular table is just a subset of the market table. So this has different sources, the district and the region. So that's what we call the use of the BM layer. It's use of logical grouping of different physical tables. So we have this market physical table, logical table, which has 3 different sources. It has a key field defined in the market key, and then we have the foreign key. In this case, it doesn't have a foreign key mentioned. Now we see this is an icon for the key. We have different attributes, and then we have the calculated field, the total US calculated field. Let's take an example of a calculated field. See, here they have an expression mentioned which is doing a comparison. If the region field in the market table has FFO region, then it has to be total US. So that's a total US calculated field created right in the repository. So that's a quick look on the dimension table. Let's look in the hierarchy. Corresponding to this particular table, assume by the name, market dimension will be a hierarchy created for this. Let me open it up completely. that's a good example of a hierarchy which starts at the all market level. So that's the grand total layer, and then you have total US, then you have the region, the district, the market, and the market key. So it creates a whole reliable hierarchy for users to create. So suppose a report is there which has this particular field, total US in the report, user will see it as a hyperlink, and when they click it, they will see the attributes for the report will be showing regional dollars, and they can keep drilling down till they reach the market key level, which is the lowest level in the report. We will show the example where you're going to really pick up objects from the different applications. That's why I'm not going in too detail in this. I'm just navigating the particular BM layer at this point of time. We talked about a little bit on the hierarchy, the dimension table. Let's talk about the fact table. The fact table is the place where you will have the most of the calculation fields. It has the keys which it joins to the different dimension tables. It has all the summation fields. You're seeing this aggregation value. So that means this particular field is aggregated. Let's open it up. So this particular field is named as unit. It has a data type integer, and it has a summation which is time the sum. The aggregations are defined in this aggregation tab, which is showing right here to us as a summation. If I change it, and let's say we do an average, it's correspondingly going to change here. So this is the place where it shows what is the final logic calculation for this particular field. Not needed at this level, but the level is an important thing, and we'll talk about that. We'll go on the table level. So we have aggregations. That's the key component in the fact table. I'll just go to cancel so that I don't say that. And then again, you can have your functions defined. You can define new columns. Your let's say I wanted to do a quick example of, let's say, instead of dollars, I wanted a US dollar. So I may have calculation which says, okay, do the case where region is equal to US, then take the dollar value, else 0. So in that case, it will know, calculate the field only for the US attribute records. So those are quick examples of what a fact table can do. It can do aggregation, it can do calculations, and definitely the central point for joining the dimension tables. One key important thing to know about a fact table is it has to define the logical levels. So this particular fact has been joined by the different dimension tables. So let's take this example. So we go in the content tab. So I clicked on the particular source and I went to the content tab. So the first general tab, it has which all tables are part of it, the column mapping, what all tables columns are mapped into this fact table, and then you have the content. The content is the place where you define and tell this fact table is joined by the product dimension, and it has to check the logical level at brand. So this is going to define you the level hierarchy which you defined previously. At what level it has to check for grouping. You have to try to define here the lowest level, unless you are setting for the aggregation. And this, it may be a little confusing at this point with this kind of things, and it's a lot of data we are throwing in right now. It will be a lot clear when we do a real hands-on. I just want you to just hang in there for a minute. So this is a good example where it's showing this particular source is going to have a where clause into it. So any SQL which is run against this particular table will have a where clause, and it will check for this particular filter every time. I'll just stop for a second and give you a chance for questions. The next layer is the presentation layer, which is the simplest of all, and that's the user view of the application. So we created a particular presentation folder at the top level is called either a presentation catalog or usually commonly called as a subject area. In this particular subject area, we have 3 different dimensions and 3 different stacks, folders into it. And it's as simple as creating the folders and pulling up, copying and pasting objects from corresponding dimensions if you want the users to have a view of. So the presentation is the most easiest layer of all the 3. It's almost like you have done all the preparation work in the physical layers, having the joins, in the OBIEE layer, the logical grouping, the drill down, the hierarchy, the calculations, everything is all prepared and ready, and it's just giving you a view to the users in the presentation layer. So that's the most simplest of it. With that, we'll conclude the navigation to the repository, the various menus, and the 3 different layers into the repository.